Yeah, I'm going to start lecture today with a short just explanation of, walkthrough of the template again, and we're going to get a little bit deeper into some things. I saw people were running into more challenges, so I just want to, go over this just a little bit deeper. Hopefully, you'll be able to understand why I made all the weird little changes and why every file has a purpose. I think that's kind of the main kind of thing about this class is you're trying to set up these tools, and I gave you the solution, but it's now your job to kind of reverse engineer the solution. Why did Ethan why does he have this make file with all these unique targets, and in the DB folder, why are all these files here? There are no extra files that I gave you. Every single file has a purpose. Cool. So I just wanted to show you this. So there is this module right here that I wrote called Blinky Runner. It's in the DB folder. And what this offers, and this is just something that I really like to do, and it's also very similar to how you will write UVM test benches. Has anyone written UVM before? Okay, cool. Does anyone know what UVM stands for? Yeah?
Universal Verification Methodology.
Yeah, exactly. Universal Verification Methodology. So there's an IEEE specification for Verilog, for system Verilog. It's a 1,300 page document of all the language features. But then there's another specification, which is the 1801, whatever. There's another specification that is just how to use Verilog in order to follow as many best practices as possible. Because generally, when writing large Verilog projects, there's so many weird edge cases and things. And so what's nice is the people who have created Verilog have told you all the proper ways to write test benches. Proper. Technically, you can write test benches however way you want, but there's this massive manual that is the UVM specification, which is it also provides you extra helper functions and things all within the system Verilog. Ideally, as UC Santa Cruz, as we're building up our chip development curriculum, eventually we'd like to have a UVM course added to where you learn the real proper way of writing test benches. Because if you go on to industry and write test benches, all industry generally follows UVM practices. So eventually we will do that. But for now, I guess all of that is kind of important, is maybe just kind of coding or writing test benches kind of just similar-ish to the way that UVM test benches kind of work. And a common thing in UVM is classes. So not structs, so I'm sure you've all kind of seen structs in system Verilog, where you can assemble together just related signals. If you have maybe a floating point struct, you would have the sign bit and then the mantissa and then the exponent. Right? That would be a struct. A class in system Verilog is only for verification, and inside of a class you will have all sort of extra kind of interfaces that will then speak to whatever module you want to speak to. And we're not going to use classes in this class, but if you would like, and I recommend, you should at least write your modules to be kind of similar to what you would imagine a regular kind of C++ class would look like. So there we go. Okay. So here I have this Blinky Runner module, but you can almost think of it like a class. And then if we scroll down to the bottom, then you can see all of these tasks here, which is kind of like the API. Which, if I want to write a test bench, so this is not a test bench, but if I wanted to write a test bench to test my Blinky module, then I would want to, all I want to do is just run these functions, these tasks. So I would want to, first I would run reset, and then maybe I could wait for it to blink on, wait for it to blink off, and then maybe I just wait for a few times to make sure that it's blinking on and off at a reasonable pace. So that's what this API offers. So now if we pull up the test bench for here, so here's the test bench, and that's exactly what happens. So here I have Blinky Runner, which I declare, and then on the Blinky Runner module instantiation, I can then access all of the functions and all the tasks inside of that with just the dot operator. So I can say Blinky Runner dot reset, which is the reset task. And then inside, I also do wait for on, wait for off, and I just wait for this for 4 iterations. Yeah, Gary.
In the reset task in the
Yeah.
file,
Uh-huh.
you use the non-blocking assignment operator for like assigning to reset, and then you add like a way from the positive edge of the clock.
Uh-huh.
How does the synthesizer even know like it's not, all right, non-blocking happens at the same time?
Mm-hmm.
How does it know you have a reset happening at the same time after, like before a delay and after a delay?
So I don't fully understand the question. I will say, so this is not synthesizable. This is entirely just for test bench related reasons, right? The test bench is calling this function, which is running this assignment, and then it is then pausing this like process, like it's pausing this thread for a little bit, and then it goes and then runs this other assignment after that.
So if you change it to an equals, like
Yeah.
just work the same thing?
This will actually do the exact same thing. Yeah. Right.
Okay.
There is, honestly, so Verilator is really bad at supporting both blocking and non-blocking assignments. So in fact, like most of the time, they're kind of just interchangeable. I would say it's not really, yeah, basically you can kind of just treat them as the same in any simulation kind of purpose. At least when dealing with Verilator, I think, and that's honestly a great reason why to use like methods instead, because what you can do is you can make sure that your reset method works, and you don't have to worry about like, oh, like inside, like in order to get it working, do I need to use like non-blocking or blocking assignment operators? Like you may be used to like writing test benches with like a bunch of assignments using non-blocking assignments or blocking assignments, and you're like assigning all these variables inside of some big initial block. And generally when trying to do that, it's very error prone. And so having kind of just nice little segments right here that like like each one of these little segments works, that is generally more popular and more liked, I would say. Yeah. Yeah. So yeah.
Does the automatic keyword just launch this function immediately?
What was that?
Does the automatic keyword just tell the synthesizer?
The
automatic.
Oh, automatic. Oh, automatic. Does anyone know what automatic means? Okay. Automatic means it's the opposite of static. So static meaning, in this case it doesn't matter, but if I have like a logic A or something, and then I set it to like 0 and have like an if statement, whatever. If this was a static method, then A would be a static member. Automatic means that this logic A is not static. Yeah. You don't really have to worry about that. Generally, you should always just throw on automatic onto everything, unless like you really need a static variable. People heard of static before in like C++, JavaScript. Okay, cool. Yeah, I won't go into it. If you don't know what it is, you can look it up. Yeah. Was that your final question?
Yeah.
Question? Yeah. So, oh yeah.
So how did the initial, initial begin blocks work and like
Yeah, absolutely. So the question was, how does the initial block work? So yeah, so in this method, in this module, so this is the Blinky Runner module, we do have one single initial block. And what initial is it will run the following process. It will run it at time equals 0. And what I have here, so I have like a clock generating process here. There's multiple ways that you could create one, but this is what I have chosen to write. This is a fairly common style of creating clocks. Yeah, where I have an initial block, and then I initialize clock, and then this block now will pause until this time delay is achieved. And then after that, then it will reset clock, or it'll invert clock, and then it'll wait one more time. And then it'll invert clock and wait one more time. So this is a clock. And this will be run at time equals 0. And I can keep going, or should I? Yeah.
I more like meant if we were going to call a task that's inside of the runner.
Yeah.
Would this run and we also have like a clock generator in our test bench?
Yeah. Good question. So so this is one initial block. But actually, in your entire design, in every single Verilog module, every single initial block is all run at time equals 0. However, there isn't an order of precedence to them. I think it's up to the creator of the tool. So some tools like will run, like BFS versus DFS versus like top first versus bottom first. There is no established order of initial blocks, so keep that in mind. But yeah, so at the same time that this initial block is being run, then also in our test bench, this initial block is being run, except I named it to always because I was fixing another thing. But let's ignore that for a second. Pretend like I said initial. Okay, so yeah, so here is this initial block. And this is the real like kind of test bench initial block that probably you're more used to, where I have my dump file here, and then I have just a display statement that says my simulation begins. I'm also setting my random number seed as well, also setting my printing for time format. And then here is where I call reset. And what this will do, so if we remember, so reset is supposed to set the reset pin, but then it also will wait. And it will wait for, what does it wait for? What does the reset task wait for? What was that?
Clock positive?
Yeah, perfect, yeah. So the reset task, you can see over here, will wait for this clock positive edge. Yeah. So, well, what is this clock at pos edge clock? What does this wait for? I mean, this kind of waits for like this delay right here. So yeah, so there's like multiple levels of like delay being set. And so in the simulation implementation, you will have kind of like I don't know, like kind of countdowns and interrupts. You'll have this big kind of like interrupt table. I can't remember what like Verilator calls it, but yeah, there's this big table of like what is the next process, like what processes are waiting on what. And yeah, so here at this moment, there's a delay, and then finally when the delay is up, then it will write this new value to clock, which will trigger all of the pos edge clock processes to continue running. And then at this time, the now reset will exit, and now we can begin running the next things. And yeah, so this is where we do wait for on, which is similar. Well, it will wait for the LED to turn on, and then wait for off. We'll wait for the LED to turn off. Yeah, and so yeah, that also makes it so that your test benches are like very kind of it's very clear what's happening. It's not just like a bunch of random assignments. Instead, it's kind of like self-documenting. You can see like, oh, like reset, and then wait for on, wait for off. And it's all like running tasks. It's self-documenting code. This is generally preferred. Cool, okay. Good. Well, this is great. The kind of in my opinion, maybe the most important part of creating this Blinky runner though, is like, so this, it's good having this nice kind of API to work with, but the main thing is that you will have several different targets for your FPGAs or basic designs, right? You may just want to simulate maybe like a certain part of your modules or things. So having a runner module to kind of abstract away the specific details for instantiating things is really convenient. So here's this Blinky runner which just instantiates my RTL. But if I now wanted instead to pull up my icebreaker implementation, so my icebreaker implementation also has a Blinky runner module. And if we look at this, you can see it's very similar, right? We have our clock here. But notice that our clock is going to be at a different frequency. And actually that's because I have chosen this clock frequency to mimic the same frequency that is like the sys clock on the board. I don't remember, is it 12 megahertz? Is that what the icebreaker board? Yeah, sure. So here, yeah, cool, 12 megahertz, that's right. So yeah, in order to mimic the official clock going into the board, we can write this. We can also, if you remember, that there's a PLL inside of our icebreaker module, right? This PLL, unfortunately, does not have a model in the, does not have a model in like the YOSIS standard cell. So if we wanted to like look up this, should I do it? I don't know. Hopefully you can just kind of take my word for it. So if you were to pull up the simulation model for the PLL, we would actually see that the module just could be completely empty. And I checked this just like a couple days ago. So yeah, the module is completely empty, which means that if we were to try to just use this PLL module in our simulation, then what would you imagine that this PLL output would produce, given that the module is unimplemented? What would be produced on this output? Nothing. Can we be more specific though? Yeah. Yeah. So it'll either be X's or it will be Z's. Yeah. That means that that there's nothing driving the output. So in the simulation, you'll see X's or Z's. Or if you're using Verilator, it will crunch it down to some two-state value. Yeah. Which is not good. That's not what we want. So instead, what we can do is inside of our Blinky runner, we can just go and manually override that. So here, I can grab the icebreaker and then .pll, and then the PLL out core. So this right here, this is like what should be driven. Right now it's undriven, but here I'm actually driving it. I'm saying assign this value to this PLL out, which is being driven right here. And so I am like in my PLL right here. In this example, I've chosen to create a frequency of 50 megahertz for really no reason, but I've chosen to have 50 megahertz. I already showed you how to run this command to generate these parameters. But yeah, so this is going to produce a clock of 50 megahertz on the actual FPGA. So what I'm doing now on the test bench is I'm just putting it at 50 megahertz here. Sorry, am I saying this wrong? 20 megahertz? I guess, is this wrong? I guess this should be 50 megahertz, and this should be 20. Okay. Okay, cool. Anyways, yeah, 50 megahertz. Is that right? I think so. I don't know. I'll think about it more later. Cool. Okay, does this PLL kind of override make a little more sense? I know a lot of people were kind of confused about this part. Should I say anything over again? Okay. I'm going to quiz you all. So can you all speak with the person next to you and explain to them what is the purpose of this bit of code right here? Why do we have this? And then also explain to them the purpose of the two separate Blinky runners. Okay. In the chat.
Yeah, because the PLL doesn't have a
Yeah, so generally there's also like how much
simulation, we just like
blinky,
and then the other ones were posted. This is going to use this specific or this specific.
might be able to edit them.
Oh, yeah.
Click on.
I'm kind of good.
It's just the PLL.
Yeah.
Yeah. Okay. Can someone explain now? Just like state it back to me. So what is the purpose of this initial block right here? Okay. Someone else? Yeah.
Simulate PLL.
Yeah. Exactly. It's meant to simulate the PLL. Why do we have this Blinky runner Ice Storm and this Blinky runner DV? Yeah.
Is it because the icebreaker module has like a different name than Blinky after synthesis?
So that's definitely one reason, right? So the icebreaker module has a different name. Then another thing is, yeah, I mean, we also need to drive the PLL. So that's another thing. Also, the icebreaker probably has different pins as well. There's just so many slight kind of variations. Like they're pretty much the same. The Blinky top module and the icebreaker top module, they're pretty much the same. But they're not exactly the same. And so having this Blinky Runner wrapper around it to kind of like standardize the instantiation. That is the purpose of having this Blinky Runner. Yeah, question.
Yeah, so like in your example and in my code when I was doing homework 1, I felt like they were almost the same. Like they were identical. Like I was copying and pasting
Exactly.
a lot. Like is there a way to not copy and paste, or is that just how it is? Like you have to duplicate your.
So it's honestly not that much copying and pasting. There is a bit, right? Creating the clocks, that's kind of like, you could create like a macro or something.
I guess for like the functions
that.
though, like the functions, the tasks, don't they do like the same thing basically?
They do, and that is, but that's fine. So in classes, so if you were using UVM with classes, there's actually inheritance that will let you do that. But also note that yes, the function implementation is very similar, but also, I mean, the variable names are different. Some of them you have like pos edge and neg edge, like reversed if you have like active low things versus active high things. Another thing is maybe we weren't using UARTs or something. Like maybe we wanted to, like something that I'm working on right now is like I just added an AXI interface to like a linear algebra unit. And so what I can have is I can have one runner that tests the AXI ports where it's sending over AXI data, but I can still do like, send vector or something, or send matrix. And I can still just use this task. And one file, like my whatever linear algebra unit AXI version, will send over that data through the AXI port, and then the other version maybe will send it over using the like internal port instead. So that is, it's just helpful, I guess, having all these separate, and then in UVM, like you'll have classes and inheritance to kind of help a little bit further. And and this is honestly, that would be a benefit of using system Verilog interfaces, but I won't talk about that because they're not well supported. Only like Synopsys tools really support interfaces, and so they're not good. So this is kind of like the workaround until eventually all tools support system Verilog interfaces. Question.
Can functions take an argument?
Yes, they can.
Isn't that one way you can get about like not copy pasting? Have the port be taken as an argument and like assign the port?
Not so much, right? Because the port is like only like right here. Like this is the port. It's defined inside the module. Oh, I see what you're saying. Well, sure. There's definitely, this is not like the only way to do this. Yeah, I'm sure there's better ways. I don't think you would want to pass arguments to these, but I think you could have like another function where you pass. Yeah, there's probably ways of doing things. Then it also comes down to tool support as well. This is well supported by Verilator because it's kind of very basic. There are all sorts of extra system Verilog features like aliases as well. Anyone use aliases before? Yeah. Anyone read the IEEE specification or like parts of it and pulled up the document? Yeah, it's a real page turner. It's I've read a significant portion of it, and yet it keeps like I'll turn to a new page and I'm like I've never heard of this like extra feature. Yeah. Anyways, okay, cool. So that is all I kind of wanted to talk about. Was just the reason why I have this Blinky Runner module. I really like this structure of creating test benches, having like your Blinky, having a runner module. This is very commonly used in UVM where you have like wrappers around things. And another kind of, I guess, side point is that, so this is a lot of copying and pasting. I guess you could call that like boilerplate. UVM is, I don't remember the exact quote, but it's a great quote that like UVM, like all UVM actually is just boilerplate. Like the amount of extra, like the amount of actual implementation that you will do on UVM will be like 4 lines of code, but you'll need like 6 files and like a few hundred lines of code. Like trying to understand and read UVM modules is like the hardest thing in the world. Anyways, so this, in my opinion, this is like a much more simplified version of what UVM does. So there we go. Cool. Okay. That's it. So I think I will let you all keep working. Remember though that your final project proposals are due on Friday. So probably take today and meet with people. Read through again the Piazza Post if you haven't already picked your groups. Project proposal due on Friday. I will